This AI will recommend you the best Starbucks drinks. Let's find out how. How many times have you wanted coffee only to have a sleepy brain buffer at the sight of a long menu? Well, I know for me, this is a frequent occurrence, and it got me thinking, if only something could read my mind and tell me what I wanted. There's recommendation algorithms everywhere for Netflix, YouTube, and surely Starbucks has one, which apparently they do, but they don't make it easy to find. So here I was, as the hour turned from 8 to 12 and still no coffee. Well, let's solve that problem. In this video, we'll be making an app which will recommend the perfect coffee.
I only fill my cup 3 times. When I order coffee, I want it filled 6 times.
To start, we're going to need to know how this recommendation algorithm works. This algorithm is inspired by Kmeans. Kmeans is a clustering algorithm that aims to partition a dataset into distinct groups by minimizing the distance between data points and their assigned clustered centroids. Think of it almost like magnets trying to find where the highest magnetic pull is. Kmeans is constantly updating and adjusting until it finds the multiple centers of masses in a given dataset. As incredible as this sounds, Kmeans does come at a downside of needing the foresight to determine how many centroids to use. Too little and you may not cluster the right data, too much and you may overcluster your data. Because this recommendation is Kmeans inspired, it works by taking the average of all your drinks and then it finds the nearest drinks closest to that value. In addition, I've also implemented the Kmeans formula on the right hand side to be able to share more drinks in the cluster of your favorite drink. Awesome! So now that we have the theory, let's see it in action. To help eliminate bias from me believing every drink I got was perfect, I enlisted the help of my family. After having them fill out their orders, we then went to Starbucks to see how the data turned out to be. Notice how the best drinks may be the drinks that's already selected. This is intentional as we may have already found our favorite drink at Starbucks. For my mom, it was as simple as a black cup of coffee, and for my dad, it was as complex as a vanilla bean frap. My sister and I ended up with the same drink even though we had 2 completely different preferences, and finally my partner got a refreshing iced latte. All said and done, everyone was quite satisfied with their drinks. There's room for improvement by adding an additional density to their drink data point so that one beverage could have more of a pulling force than another, however, that might make the UI too complicated. Now that we've seen this all in action and know how it works, let's get to the code. To start, we're going to need data, and sadly there was no datasets that had the parameters which I needed. So I pulled out my expert coding skills and Ctrl-C and Ctrl-V all the data into Google Sheets. After that, we need to standardize our data. Because a metric of calories unstandardized can make our Kmeans too dependent on that one feature while ignoring the rest, I chose to place all of our data to fall within a range of 0 to 1. To perform Kmeans, we'll need the Pythagorean formula. Luckily, no matter how many features we have, this formula holds the repetition of the square root of the summations of all of our features squared. Next, we need to create a class to represent our data points, and a function to find which cluster centroids is closest to that data point. Finally, we keep looping through this until we either no longer update the centroids anymore, or we reach the max amount of predefined iterations. That takes care of the Kmeans algorithm, and we can see it in action here. I like to initialize my Kmeans with the centroids that are on top of known data points in the graph. However, there are some who prefer to use randomness instead. Lastly, the algorithm that's inspired by Kmeans lives in the GUI and works as the following. We'll take all the drinks that the user enjoyed and find the mean of their location. This means that if someone likes something super hot, such as an espresso, and something super cold, like a coffee frap, you'll have a mean value more in the middle of an iced coffee. After that, we iterate over the drinks in our dataset and find how close they are to our mean point. This is why if we selected just one drink, our top recommended drink will be that drink. Finally, we sort all the drinks based on their distance, and the shortest 5 drinks are our picks. And there you have it. There's also a GUI, however that can be found in the comments and descriptions below along with the full code. If you enjoyed this video, you should check out this other one and consider subscribing. Till next time, friends!